There are an incredible number of pump designs out there. They're really an ancient technology, one of the oldest machines that was ever invented were pumps, and there's so many different types. But there are two categories into which most pumps fall. Most of the pumps that are used in industry certainly fall into one of these two categories. So we'll talk about those two. Those two categories are positive displacement pumps, sometimes called PDPs, or dynamic pumps. So positive displacement pumps first, they work by moving a fluid by actually causing a volume change. So here's an example of a positive displacement pump. This is a piston pump, and it's pretty obvious how this would work. So you put a one-way valve on the inlet, and it's called a check valve. The fluid can only go one way through the valve. It can only go in this side. And then you have put a one-way valve on the other side as well, and it can only go out that other side. So as you draw the piston up, it's going to pull fluid through the inlet, and fluid will come in and fill the piston. And then you push the piston back down, the fluid will try to go back out as the way it came in, but it can't because the valve will check and close, and then the outlet valve will open. So you'll literally force the fluid out the other side as you decrease the volume in the piston chamber. So the piston chamber will continue to increase its volume to draw fluid in and decrease its volume to force fluid out. Very simple pump design, and a very good one. I mean, the advantage of this is you really can force even very, very viscous fluids with this kind of a pump, because the piston is going to drive that fluid out as long as the piston is strong enough. It will force fluid out and it will keep the fluid moving. So they're very good for dealing with very viscous fluids. They're also good at overcoming very large pressure gradients. If you want to drive fluid up a high height, this kind of pump is good because they tend to be very strong and capable of generating a lot of pressure. So that's an example of a PDP pump. There are lots of different types of PDP pumps, many different ways of achieving the same basic idea of changing volume to force liquid to move. Your heart is actually another example of a PDP pump. Your heart, your ventricle has your check valves on it, same as that I've drawn here. Your heart cavity expands, drawing blood in from one side, and then it contracts, shrinking that volume and driving blood out the other side through a different valve. So that's PDPs. The problem with PDPs, they do have some drawbacks. PDPs deliver pulsating flow, so that's not great. PDPs, by their nature, always deliver pulsating flow. So again, think of your heart. You don't have your flow isn't continuous and smooth with your heart. It pumps and then it doesn't pump, and then it pumps and then it doesn't pump, and then it pumps. Your body actually evens that out a bit by having your veins be elastic. So your veins actually expand as the heart pumps, and then they contract after the heart contraction is stopped, and they continue the blood moving even after the heart has stopped pumping. So that's a clever technique to achieve sort of continuous flow in a pulsating system. But the reality is the pump itself is delivering a pulsating flow, and PDPs almost always do that. So they really can't deliver a smooth, continuous flow. Sometimes you don't care if you just want a certain amount of liquid to be pumped over a certain amount of time, and you don't need it to be continuous in terms of its rate of delivery, then that's fine. Or maybe that pulsing can be fast enough that you just don't care, depending on the engineering application. But it is not possible with this type of pump to have a truly continuous stream of fluid that moves at a constant flow rate. The dynamic pumps there again, dozens or thousands of versions of this. Here's just one example. They add momentum to the fluid by means of fast-moving vanes or blades. So I've drawn one here that's fairly common. The fluid enters the center of this pump. These blades are spinning as drawn in this direction, and so they drive the fluid out to the edges, and then of course then force it out the outlet as they continue to capture more fluid, and by rotating very fast, imparting a large pressure to them, and then driving the fluid through. So dynamic pumps can move a lot of fluid. So if you want to move a lot of fluid, dynamic pumps are great. Dynamic pumps also provide continuous discharge. So dynamic pumps provide continuous discharge So unlike the PDPs, once this thing gets going, you can just have a stream of water that's coming out at the same rate all the time. And they also can provide very high flow rates. So if you want to move a lot of fluid, generally speaking, dynamic pumps are the way to go. And you can obviously imagine making these blades very, very large and moving the rotating very, very fast, and you just get huge amounts of fluid moving through the system. One of the downsides of dynamic pumps is that they must be primed. So if there's not water in them, or if you're using water, for instance, if they just have air when it's a water pump, then it simply won't do anything. If you turn it on, you'll be moving air, but you won't suck any water into your pump. So you have to fill it with water to get it started, or fill it with whatever fluid is you need to do. That's not necessarily true of PDP. PDPs will actually pull a suction, they'll pull a vacuum. So they will, a well-designed one will, pull the air, pump the air before it starts pumping the water. You don't really need to prime it at all. It can just go. So, but both pumps, you'll see a lot of both of these. If you go even to Home Depot, I did this recently. I was looking for a PDP pump, and almost all the pumps are dynamic. They're almost all this kind of impeller pump where you spin something and pump fluid through fast. But they also have positive displacement pumps because they have applications, as I said, where you want to really overcome a large pressure barrier or high resistance.